What is up, team? Today we're talking about interpreting inequalities. You'll see the learning target right above me. I can interpret inequalities from words to algebraic expressions and then solve. So these are the most applicable things that you're going to see in your day-to-day life. We are going to create inequalities with them, of course, and then solve. So we're going to make it apply to our math class as well. A lot of what we're going to talk about today has to do with money, having enough money, how much can you buy, how much time can you spend here or there. Now, when you go to a grocery store, you're using these ideas if you have a limited income, which we all do. Maybe you're not actually busting out a calculator and creating these inequalities, but you're using all of these same ideas. A lot of times, it would actually be more efficient if you created inequalities like what we're going to do today than what most of us do by throwing things in our cart and hoping we have enough once we hit the checkout line. All right, let me paint a scenario for you. You're going to a pet store, probably PetSmart, where pets are family, of course, and you're buying some things for your dog. You're buying a bag of food, and you're buying some toys. And you want to buy as many toys as you can afford with the money that you have. So here's some details. The bag of food costs $15. We only need one bag of food because that's going to last us quite a while. And then the toys, there's a bargain bin there, and where the toys are $3 a piece. So every toy you buy, there's an additional $3 on your bill. And you have $25. That's the scenario that we have. So we're going to take out all the important pieces here and then create our inequality to see how many toys we can afford. Okay, here's the important pieces of information. One bag of food is $15. We know we only need to buy one bag of food. Toys are $3 each. We don't know how many we're going to buy yet. We're trying to get as many as we can, but the total amount of money that we have to spend is $25. So let's create an expression or create an inequality using this information. So I'm going to say one bag of food. I'm going to abbreviate that. I'm just going to say food plus toys. And then over on the other side, I'm going to say total money. So we need to create an inequality here. Which side is going to be greater? The money that we spend on the food or the toys, or the total money that we have? Well, the greater one has to be the amount of money that we have. Well, it could also be equal to. So the total cost of the food plus the toys has to be less than or equal to the total amount of money. Meaning we can spend up to $25, including $25, but we cannot spend more than $25 because we just don't have it. They're not going to let us leave the store with toys that we don't pay for, right? So now let's plug in the information. If one bag of food costs $15 and the amount of toys are $3 each. Oh, yikes. Okay, so $3 each. We don't actually know how many we're buying. So here we're going to have to use a variable. The variable is going to stand for the number of toys we're buying. So let's go ahead and use the letter T. So we have 15 plus 3T is less than or equal to the total amount of money, which we are told is $25. Great. Now we have an inequality. And we can solve this. We know how to do this. We've done a ton of these. So we'll subtract 15 from both sides, and we'll learn that 3t is less than or equal to 10. And when we divide both sides by 3, we learn that t is less than or equal to, well, it ends up being 3 1/3. If you put it in your calculator, if you do 10 divided by 3, it'll say 3.3333. That's 3 1/3. Okay, so we're trying to find out how many toys we can buy. We want to maximize it. And we learned that we can buy 3 1/3 toys. If you go to the pet store and you say, hello, I would like to buy 3 1/3 toys, are you going to be able to do that? No, absolutely not. They're not going to give you a third of a toy. That's ridiculous, right? So what's going to happen is you can buy 3 toys and you're going to have a little bit of leftover money. That's fine. So what the question's asking here is how many toys can we buy in addition to that bag of food for $25? Well, our solution here then is we can buy 3 toys. Why did I put a 3 there instead of an S? There we go, 3 toys. That's our solution for this problem. Here's another example for you. Let me paint you a little picture. Say that you have to go to bed in exactly 5 hours, but there's some tasks you want to accomplish. You need to eat dinner, you need to brush your teeth, you need to do some homework, and you want to watch as many episodes of Survivor as you can before bed. So you want to maximize the number of Survivor episodes, complete Survivor episodes that you can watch. So we're going to create an inequality, and we're going to figure out how many episodes of Survivor we can watch in 5 hours while still accomplishing all the other things. Keeping in mind that when we watch our show, we want to give it our full attention. So we're not going to watch while we're eating or anything like that. Okay, I've captured all of the important details here on the screen. Say it's going to take 45 minutes to do your homework. Say dinner is going to take 30 minutes. Say it takes 5 minutes to brush your teeth. And we know that each episode of Survivor is 32 minutes if you don't have commercials. So each episode is going to be 42 minutes here. The total time you have is 5 hours, and then I converted that into minutes. So we have 300 minutes to accomplish all of these things while maximizing the number of complete episodes of Survivor that we can catch. So let's create our inequality. We know we have to do homework, so let's capture that. We have 45 minutes. We have to do homework. We have to eat dinner, and that's going to take 30 minutes. We have to brush our teeth. That's a requirement, so that's going to take 5 minutes. Now, for the episodes of Survivor, we don't actually know how many we're going to watch. We know that each one is 42 minutes long, and we're going to put a variable in here. I'll call it X. X is going to stand for the number of episodes we're going to watch on this, in this example here. And the total time we have is 300 minutes. So it's kind of like the money example, really. We have 300 minutes to spend, and we can't spend more than that because we don't have more than 5 hours. Say it's a hard deadline, gotta go to bed in 5 hours. So we can go up to that 5 hours, but we can't go over it. So our total time of activities, homework and TV and whatever, is going to be less than or equal to this 300 minutes. And now we have to solve. This one looks more complicated than the last one, but it's really just because we need to combine like terms. So we'll do 45 plus 30 plus 5, and we learned that that's 80. So there's 80 of our minutes already taken up, plus 42 minutes per episode, which is less than or equal to 300 minutes. Okay, now we're trying to get this x by itself. It's going to take 2 more steps. Subtract 80 from both sides. We learned that 42x is less than or equal to 220 minutes. Now we need to do some division. I would definitely recommend grabbing a calculator for this one. I'm grabbing mine right now, and we're going to divide both sides by 42. So in my calculator here, I'm going to type in, 220 divided by 42, and what comes up is 5.2380, blah, 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 blah. So we said we only want to watch complete episodes. We don't want to start without finishing. So if x is less than or equal to 5.238, blah, 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 how many complete episodes can we catch? Well, we can catch 5 complete episodes. 5 complete episodes. Boom, boom, boom. There we go. That's our solution. That's what the question asked for. Now, do I actually think that you're going to sit down every night and create inequalities when you're planning out your evenings? No, probably not. But you're using these ideas. Maybe you don't actually express it like this, but in your head you're kind of rationing things. Okay, I have to do this much, I have this, and that's going to take me to this time, etc. If you want to get exact answers, you could do something like this. Generally, in real life, no, I'm not doing this. I'm using these ideas, but I'm not actually doing all of this math. But we're going to practice doing the math. Let me know if you have questions. Good luck.